Next topic is ARP. 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 ARP also have the two component. The function of the ping was ping was to test the connectivity between the devices, and the function of the ARP is to find out the MAC address with the help of IP address. The function of ARP is to find out MAC address with the help of IP. If you know the IP or if you know the name of a person, you can search his address where he is living. We have the two components of the ARP. The full form of the ARP is ARP resolving ARP protocol or ARP resolution protocol. Address resolution protocol or आपके पास address resolving protocol. Both terminologies exist on the internet. ARP also have two components, ARP request and ARP reply. ARP request, and the second is ARP reply. ARP works on layer 2. ARP works on layer 2 of OSI model. In most of the training center, they discuss the OSI model in the beginning, but I will discuss OSI model in the last after finish CCNA. Layer number 3. We will discuss in the OSI model. Ping works on L3, network layer. Ping works on network layer, layer number 3. It's a logical layer, they can be changed anytime. And ARP works on the layer 2 of the OSI model. ARP request is always broadcast. Always broadcast. And the information on the layer 2 known as frame. Whatever the information on the layer 2, information, or you can say data, the information on layer 2 is called frame. So if any device wants to know the MAC address of the remote device, that means we are asking about the layer 2 terminology. ARP works on the layer 2, and on layer 2 we are demanding the MAC address, and MAC address is 48 bits binary number or 12 character hexadecimal number. MAC is either 48 bits binary number, or if we represent into the network device in hexadecimal, it came out 12 character. With the help of the ARP request, we can find out the MAC address with the help of IP address. If we know the IP address of the remote machine, we can find out the MAC address of that machine. Whenever we want to know the MAC address of the remote machine, the source machine will send ARP request to the destination machine. For example, if we have the machine A and machine A is connected to machine B. We remember data or information cannot be delivered till the machine don't know the MAC address of the remote machine. If I want to give this remote control to you, you must be physically exist, not logically. You are getting? Whatever the information I am broadcasting or announcing, it will delivered on the physical object. Virtual connection cannot be formed till physical connection is not exist. If you have the internet connection at your home and you have the wireless connectivity, each wireless connectivity have the physical object. Your laptop is physical, your ADSL link router is physical, but there is no connectivity physically between the laptop and the router that is providing the IP address to you. But virtual connection is forming. So if we want to send information from one machine to another machine, we need the MAC address, physical location. Machine A, let's say, have IP address 192.168.100.1. Machine 2 have 192.168.100.2. We want to send some information to machine B. Machine A cannot send any information to machine B till machine A doesn't know the MAC address of machine B. The MAC address of machine A is, for example, AA 12 times 1, 2, 3, 4, 5 and 6. And for example, machine B have the MAC address B. We know that, but machine A doesn't know what is the MAC address of the machine B. Because we are the administrator, we know what is the MAC address of the machine B. 1, 2, 3, 4, 5, 6. Whenever administrator want to send any information to machine B, either you want to ping from machine A to machine B, your request will not be completed. If anybody is going to the CMD of machine A and write down ping 192.168.100.2, you are sending the echo request. Your echo request will not out from this port till machine A doesn't know the MAC address of B, because you cannot deliver anything to the remote location, because you are sending the information, you are delivering the information. You don't send the information on the remote location till you don't know the physical location of the machine B. That's why this machine will suspend your request, whatever you are saying to the machine, and the first information will exit from this machine is ARP request. You are entering first information ping 192.168.100.2. You are saying to this machine, contact to this machine, but this machine cannot move to the B because this machine doesn't know where B is located. This machine know the name, because you are defining, administrators defining contact to 192.168.100.2, but this machine doesn't know where B is exist in the scenario. Then that machine will send the ARP request. In ARP request, the machine A will send the following information. Machine A will send source IP. Machine A will send source MAC. Machine A know the source IP. What is source IP? 192.168.100.1. What is the MAC address of machine A? A 12 times. Source machine A is also knows the MAC IP address of the remote machine, destination IP, but destination MAC is not known, that is unknown. Machine A is sending the ARP request. My IP is 192.168.100.1. My IP is 192.168.100.1. My MAC is AAAA. I want to know the MAC address of 192.168.100.2. In ARP request, what is the message of machine A? In ARP request, what is the message of machine A? My name is 192.168.100.1. My house is AAAAAA. I want to know the house number of 192.168.100.2. Anybody hearing me? I want this one. This message will send to the machine B as a broadcast, because machine does not understand the language, machine is understanding the number only. What is the broadcast? How the device will understand? The coming information is broadcast. Coming information is also for me. We are sending the ARP request via this address FFFF 1 2 3 4 5 6 12 time FF is the language of ARP request. If any frame, information on layer 2 is called frame. If any frame is received via machine and the language is FFFF 12 times, it means that information is for everybody. When this machine will listen, this machine will open the format and find out my name 100.1 and 192.168.100.2 is mentioned in that information, and if somebody is calling to me, so that my duty is I will reply to the sender. This machine will send ARP reply. This machine know my source IP. My source IP is this one. My source MAC is this one, and destination IP, because we have sent machine A send the source IP, that's become the destination IP. This machine know the destination IP. My IP is 192.168.100.2. My source MAC is BBBB. I want to send the information to 192.168.100.1 destination IP, and the location of destination machine is with respect to the B is AAAA. That's why ARP request will not be broadcast, it will be unicast always. ARP request always broadcast, ARP reply always unicast. Now you have sent the echo request. Now the echo request will proceed, because echo request was suspend first. When you will send the ping 192.168.100.2, your request was not proceed, that request was suspended. When the source machine will get the MAC address of the remote machine, now this echo request will proceed. Echo request will proceed in step number 3. The first information, the device will send ARP request, then ARP reply will come. When the ARP reply will reach on the machine A, the machine will send the ARP request. ARP request will not proceed till we will not get the MAC address of the remote machine. We cannot take out any decision to move anywhere till we don't have any address. If we have the address, we will move from the house. Similarly, the machine will not go to the B till A machine will not get the MAC address of the B. With the help of the ARP request and ARP reply process, when the A machine will get the ARP reply, get the MAC address of the machine B, then A machine will send the ARP, A machine will send the echo request, and in fourth step we will get the echo reply from the machine B.